Is my screen visible, ma'am? My screen is visible, ma'am.
Yes, Mr. Rishikesh, it is visible.
Namaskar and good afternoon once again. Here I am going to present analysis of waste rubber tires uses in concrete road construction. This is presented by me. I am Kumar Sikesh Anand, a final year student of BTech in Civil Engineering. Here I will cover in 7 parts, that is abstract, introduction, objective, materials and experimental programs, test result and discussion, conclusion, references. Abstract. In this paper, we have examines the normal concrete and the concrete mixed with waste rubber tires. Here effort had been taken to identify the potential application of waste rubber tires in civil engineering and construction project. The main object of this study is to focus on utilization of available waste or recycled plastic materials and waste rubber tires presently that is in abundantly and easily available, which can be used economically and conveniently away. In this present considerations, regular M25 grade cement concrete cubes are casted and compared with M25 grade of concrete cubes by replacing 0%, 5%, 10%, 15% and 20% of rubber tire aggregate with conveniently coarse aggregate. Introduction. In developing nation like India, there is a continuously increment in urbanization, coming about rapidly increment in utilization of vehicles that will create an enormous amount of waste tires. When we that is the waste tires are additionally generated, that is biodegradable, and on disposal there is threat to environment pollution. To benefit the general public, especially to have the improved condition, the need to conserve energy and conventional resources, that waste tires can be utilized into concrete construction. Here we can see the picture perception of rubber tires as an aggregate. Here we cut the rubber tires, and that times that is pictures. Here we study the physical properties. Here we have got after test, that is when we tested coarse aggregate, we have get the percentage of water absorption and specific gravity. Then the coarse aggregate possesses 3.62 and the specific gravity 2.76, fine aggregate 3.33 and 2.66 as a specific gravity, and the coarse rubber tire aggregate possesses 5.54% of water absorption and a specific gravity is possesses 1.05. And the chemical properties that is taken from PFAS, this is as it. And objective, the our objective is to basic property of concrete, that is slump value, compressive strength and flexural strength, comparing the result of different proportion. To study and examine the cement concrete when aggregate is partially replaced with waste rubber tires aggregate at 0%, 5%, 10%, 15% and 20% by weight of coarse aggregate. To examine M25 grade concrete at a time period of 7 days and 28 days respectively after the curing. To investigate the optimum use of waste tires of rubber as a coarse aggregate in concrete composite materials. This is not only minimize the pollution occurred due to waste tires but also minimizes the uses of conventionally aggregate. It will be beneficial for not only society but also for technical growth of our nation. Materials and experimental programs. We have casted the M25 grade of concrete with the design mix, and by the replacing the coarse aggregate to the rubber tire aggregate in the amount of 5%, 10%, 15% and 20. And we have measured the compressive strength at 7 and 28 days, and we have checked the durability of concrete. This flexural strength of specimen was determined in the flexural testing machine according to Indian standard 516 1959. Here we have used the material cement, coarse aggregate, fine aggregate, water as per water cement ratio, and the rubber tire aggregate. Test result and discussion. The other four concrete mixes were made by replacing the coarse aggregate quantity with 5%, 10%, 15% and 20%. The one that is casted, that 0% of rubber tire aggregate we have used there. And the standard cubes mold size of the 150 mm 150 mm by 150 mm we have used for casting the cubes. Slump value is also investigated at fresh stage of concrete and after Mm, we have checked the strength, compressive strength and flexural strength after the different proportioning at the age of 7 and 28 days. Now we have see the more clear results in the tabular form. Here experimental program, here we have experimental program, here we have tested after the preparing of concrete, we have molded it, and after its hardening state we have in the fresh concrete stage we have measured the workability, that is in normal concrete we have found the workability slump value, that is 115 mm. In a rubberized concrete sample at 5% 95 mm, at 10% rubberized concrete sample 80 mm, at rubberized concrete sample 15% 75 mm, and rubberized concrete sample at the value of rubber tire coarse aggregate 20%, we have found the workability 65 mm. Uh, in hard state we have measured the concrete properties, that is compressive strength. Here we have used the water cement ratio 0.48, and after 7 days and 28 days we have measured the compressive strength, that is shown on left side table. Here we can take a look, and in fractional strength, that is in right side table, here we have noted at same we have used the 0.48 water cement ratio, and we have noted fractional strength value in megapascal after the curing of 7 days and after 28 days. Conclusion: as per the result data obtained based on this study and investigation, the replacement of conventional aggregate with the waste rubber tire aggregate results in comparable effects in the concrete. The following conclusion can be drawn. It is seen that the compressive strength as well as the flexural strength drop as the addition of percentage of rubber aggregate increases. In concrete, at 5% and 10%, substitution of rubber aggregate may accomplish the compressive strength as that of the ordinary cement for certain couple of modification, like adding additional silica or by supplanting concrete. Rubberized concrete strength characteristics may be improved by adding admixtures and by improving the bond properties of rubber aggregate. It can be concluded that despite the reduced compressive strength of rubberized concrete in comparison to conventional concrete, there is an enormous market for the concrete product in which inclusion of rubber aggregate would be feasible. The rubberized concrete is the light unit weight process, may be suitable for architectural application. Most of the time it is seen that designers and contractors go to high strength and expensive cement concrete to get not many improved properties such as impact resistance in parking area and lightweight structure for particular specific application. The rubber aggregate can be better alternative for conventional aggregate in concrete construction. Waste rubber tire aggregate tackles the issue of permanent deformation and thermal cracking in pavement in for such amount at the time of application. When it is utilized for pavement, it can withstand higher temperature. It can likewise oppose the bad impact of water. With all these, it is a decent saving as well. Hence, in concrete, it is suggested to replace 5 to 10% of waste tire aggregate, rubber aggregate with coarse aggregate, which will be the ideal substitution in concrete composites. Here we have used such references. We can have a take a look. Thank you so much.
Okay, thank you, Rishikesh. Now, with this, we come
Thank
to
you,
the
ma'am.
end of the session. So, this was the last presentation. So, does anyone has any questions for Rishikesh?
No, what was the reason that due to addition of rubber, your workability is decreasing drastically?
Because sir, it possesses the water content is more, sir. Water absorption capacity is more, sir.
Rubber want to, how much percentage it is absorbing
5.54%, sir, water absorption capacity with the specific
of
gravity of,
rubber?
yes, sir, coarse tire rubber aggregate.
Pardon?
Coarse tire rubber aggregate, yes, sir, that is rubber tire aggregate.
It is absorbing about 5% water.
Yes, sir, 5.5% water.
Okay.
That is
And
the
in
reason.
flexural test, you have used 2-point loading or single point loading?
Single point loading, sir.
Flexural strength.
Yes, sir.
Okay, thank you, Rishikesh. Thank you, sir. So now
Thank you,
with
sir
this,
and
we come
ma'am.
to the end of the session. So I would like to thank all the participants for showing their cooperation and support. And I want to, sincerely express my gratitude to Dr. Binod Singh. Thank you so much, sir, for being a part of this session and, taking out time from your busy schedule and the way you guided our students and, shared your knowledge. So that was really sweet of you. So thank you, sir, and we're really honored to have you.
Thank you. I want to make one correction. Actually, now I am not with ABS Engineering College, but I am working with
Okay.
Ajay Kumar Garg Engineering College.
Okay, sir. Okay.
Thank you.
My apologies, sir.
No, thank you.
Okay. So thank you all, and I'm ending this session now.
Thank you, ma'am.
Thank you.